Hi all. Today we're going to talk about static NAT. We're continuing with our ASA firewall labs from before. I think in the last one we covered some dynamic NAT and policy NAT. And again today we're going to get to static NAT and policy static NAT. So let's just get right into it. So in this case we want to, static NAT really is creating a one-to-one translation. The translation is bidirectional, and the syntax is, generally speaking, although not always, because you can do it different, is going to be like this: static, and then more secure, less secure interface, but then the less secure, say 10, and then more secure IP. I'm going to do throw the net mask in this time, but when you want just a 32-bit mask, host to host, you can just put an enter after your IPs here, and it'll put in a host mask for you, or enter a host mask. Just show you that. Generally speaking, you then have to write net mask and then your mask. So what we're saying here though is, so static, more secure, less secure interface, less secure, more secure IP. So when this IP, it does twofold, right? Because it's a bidirectional net. When this internal IP goes to the internet, is going to be translated to this public IP. So this becomes our PC1, because PC1 over here is our 10.10.10.10 host. PC1 is going to look like this IP address as a source when he goes out to the internet. And conversely, this opens, like I said, bidirectional. Assuming the outside ACL allows it in, you can connect to PC1 by pointing to this public address, right? So just show you that quick. We'll go to PC1, and if we connect to pub1, say, .10 on 80, we got through. And over here, if we do a show xlate in the firewall, you can see that PC1 locally did get netted globally to the static that we made him, .10 on the outside, and show con, you can see that outside IP, .10 on port 80 we're connected to from the inside source here. We'll just break that. I'm going to do a quick no on the static, and we'll show you another one. You can do this as well. You can do a static. Again, we'll do more secure, less secure. So we'll do inside DMZ. And so over here, when we did more secure, less secure, we actually truly natted our private IP to a different public IP. In this case, we're going to net our inside IP to itself using static NAT on the DMZ. So, again, I was telling you, it's more secure, less secure interface than less secure, more secure IP. We put our more secure IP twice here. So what that means is, again, the bidirectional NAT, when PC1 goes towards a DMZ, and we're going to connect to DMZ server 1, he will look like his real 10.10.10.10. He won't be natted to something on the DMZ segment, because if we put in 20.20.20.10, well, we couldn't actually have a conflict because we have 20.20.20.10 here. But if we put 20.20.20.50, say, then when PC1 went to the DMZ people would see him as 20.20.20.50. And when people on the DMZ wanted to access PC1, they'd point to the 20 address, and it would be natted into the real. But in this case, if we connect over to 20.20.20.10 on 80, you can see we're connected. And in the firewall, show xlate, our local IP has been netted to itself. It's still 10.10.10.10 on the DMZ. And show connection, you can see we're connected from PC1 to DMZ server 1 on port 80. So I'll just quickly break that. Let's talk about, we can do static NATs, we'll say from inside, outside, so more secure, less secure. And then we can specify a protocol here, and we can put in the less secure IP that we want to NAT this guy to, say 100, and then our port 80. We can even say 8080, let's say, and then our more secure IP. So this is the guy on the inside, and then our more secure port. And then you would do net mask. We don't have to. It's 32 bits for us. So let me just show you that quick. So it's more secure, less secure IP, less secure IP address, and less secure port number. So meaning the egress IP address and port number. So what our ingress IP address and port number is going to be translated to. So we're translating the 10.10.10.10 host to 100, 100, 100, 100 when he goes to the internet, and again bidirectionally, so you access this IP and you get to this IP on the inside. We're also translating the port. So well, let's show you. If we go to pub1 here, out on the internet, way over here, right? If we go to pub1 and do a telnet to, that was right, telnet to 100, 100, 100, 100 on 80, on 8080. See, we got an open connection there, and in the firewall, if we do a show xlate, you can see that our local 10.10.10.10.80, there's a translation to the 100 on 8080, and if we do a show connection, you can see that outside pub1 server is connected to our internal host on 80, but we actually pointed to 8080, to the public IP on 8080, and he translated not only, according to the static, not only the public IP he translated to the internal, he translated that egress port to 80 on the ingress side. Okay, so let me just, what happened here? Oops. There we go, let's break that. Okay, go back to the firewall. I just quickly get rid of that static. And then I'll show you one last one, which is policy static. So if we do a static, more secure, less secure interface, actually, sorry, policy. So we're using a, like policy NAT was, we're using an access list here. So let's create an access list called pub1 HTTP, right? And we're going to permit TCP host. Let me write, we're on the DMZ, so we'll use the 20. Let me just write this out, and then we'll go back and talk about it. Okay. Well, let me write the static as well, and then we'll stop. We'll pause quickly. I'm trying to go sort of fast because I'm going to run out of time according to my allowable YouTube limit, right? More secure, less secure. We're going to, on the less secure IP, make him say 100, 100, 100, say 10, 80, and then we're going to reference the access list. What did I miss? Oh, sorry, the protocol, right? TCP. And we're going to create an access list. We may point it to pub1 HTTP. Okay, talk about that quickly. So remember we said the interfaces were more secure, less secure, then the IPs were less secure, more secure. So it's the same, right? We've got more secure, less secure, less secure. This is what we're going to NAT our more secure IP to, but the more secure IP is referenced in an access list. Here's the IP, right? Our DMZ IP, and it's also referencing who's going to access it. So we've said anyone. So we're assuming it's a web server because it's a web server on the DMZ, right? So we're assuming anyone's gonna want to connect to it from the internet. So basically, it's saying when anyone comes in to this server, really pointing to this IP, it's going to be allowed in. The translation is going to allow anyone coming into this fake IP on the egress side to get to this ingress IP. So let's just have a quick look. Again, if we telnet to, oops, that was awful. Telnet to, what did I make that? .10, 100, 100, 100.10 on port 80. We should be connected to the DMZ, right? We've got an open connection. We should do a connection into, and we did. So our globally NATed IP again was .10 on the outside. Our locally NATed IP is the DMZ IP .10, DMZ server 1, and we didn't do an 8080 to 80. We left the port 80 go to 80. And if you do a show connection, you'll see that pub1 is the host that's connected into the DMZ server 1 on port 80. There's a lot more to it. You can do outside NAT, so you can go opposite of what I've been telling you. Put your less secure IP and then your more secure, less secure interface, more secure interface. And what you do then is you're NATing the source as it comes in. So you're NATing someone on the internet to whatever you want it to be. So you can route to it, for example. There's stuff you can add on the end of the static, like session limits and embryonic connection limits. There's a whole lot more you can do with statics. This is the the basics of stuff you'll see in use every day. If you want more detail, you have any questions or comments, leave them on YouTube. I'll do my best to get back to you. Thanks for watching.